I'm going today to demonstrate a shop-made tool that you can use to be precision plumb to the world. At times, after an earthquake, a machining incident where somebody gets, where a part maybe collides with a column of a machine, particularly on a vertical boring mill, something like that, and you don't have a live spindle, you want to verify two things. One, that the table is level to the world, that it is the column is plumb to the table, and you may not have a live spindle to just use a dial indicator to verify perpendicularity. So now you can use a laser or something like that, and you got levels and even electronic levels nowadays that can get you pretty close. But to accurately check plumb, what we've used in the past was something that's more or less shop made, and it doesn't amount to much other than a anvil that was made to go on a inside mic, and I made mine with a V block on it so it easily to go on round surface, keep contact, and of course it's got some flats on it too. A lot of vertical boring mills have rectangular spindles. I'm using a electronic edge finder, and you could use a touch-off tool, electronic touch-off tool as well. Similar approach. Basically, you're just conducting electricity. And I've tried light bulbs. They don't seem to work very well. They're a little slow, where the LEDs are a little faster, more sensitive. But basically what you do is you come up and you go to the top of your column, and your wire is supported by an insulated support, like a magnetic base with something that non-conductive to run the wire through. And you adjust your mic until you see your LED light up, and you adjust it until it won't light up. And then you come down to the bottom and do the same thing. And if it doesn't use the same reading, then you may have to adjust the level of your column. Once you adjust the level of your column, get it satisfactory, and you can do mathematically, you can calculate your angle based on your difference to see if it's acceptable. It doesn't have to be perfect depending on what you're doing. But if you do get it perfect, or as close to perfect as you can, and you can get with an inside mic, you can get within a half a thousandth depending on the length of your column. The longer your column is, the more precision that is. But then you can also verify straightness of your column by using the same reading. You can actually go every so many inches, and you can chart any variation in straightness then, once you have it plumb. So it's an interesting tool, it's an interesting approach, and if you don't have like a laser or something like that, it is a method of verifying that your machine is plumb, especially on a large machine, or any column. It doesn't have to be a machine either, but any supporting column could be checked the same way if it conducts electricity. Or if you want to put electrical surfaces on that and hook them up so they would conduct electricity, you could do the same thing. And like I said, it's just a shop-made little tool, and using basic equipment. This is a close-up view of the equipment used to set up and measure a column for plumb. The silver bowl in the video is filled with oil and is used to help dampen the movement of the plumb bob while you're taking measurements.